Welcome to solverfy.
Okay, we're going to use Gauss Jordan row reduction to solve the following system of equations: 7x minus 6y equals 4, and 21x minus 18y equals 12. So let's put this in our augmented matrix, right? With our x row having a 7, our y row having a negative 6, right? Sorry, column, our x column having a 21, our y column having a negative 18, and our solution column having a 4 and a 12. Okay, so this is the augmented matrix, and now let's start doing our row operations. Well, right off the bat, I can tell that, at least as far as the x column is concerned, right, that x2 is 3 times x1. So that's often a good place to start, is that you can notice that there's a multiple of one line and another line. In this case, line 2 is a 3x multiple of x, right? So we could do, for example, L2 minus 3 times line 1 as our first operation. Okay, it means line 1 will stay the same, remains 7, negative 6, and 4. But from line 2, we will subtract 3 times line 1. Okay, so 21 minus 3 times 7, that's 0. Negative 18 minus 3 times negative 6, well, that's going to be 18 plus 18, also 0. Okay, and finally we have 12 minus 3 times 4, also 0. Okay, well, now we've effectively figured something out, and that's that line 2 was equivalent to line 1 multiplied by 3, which means our system was underdetermined, right? So at this point, there's no explicit solution for which we can solve x and y separately. That is, here we would say there is no solution, right? And why did we know that? Well, because we have a row of zeros, right? Which means this equation is telling us nothing. It's effectively non-existent. We have 2 variables and only 1 equation. We need, if we want to solve 2 variables, to have 2 meaningful equations. But in fact, one of the equations we were given was simply a multiple of the other one. Right? We go all the way back to the beginning, we can kind of see that 7x minus 6y equals 4 is just 1/3 of 21x minus 18y equals 12, right? They contain the exact same information, right? And so our system is therefore underdetermined. We don't have enough information about the relationship of x and y to solve either one for concrete values. We just know this much, a single equation's worth. So it's like if we took the same equation and said it twice, right? It doesn't tell us any more.